So even though we talked about the importance of respecting that hidden relationship between the two equations and the parameter, sometimes it's hard to tell what's going on from a pair of parametric equations. And as a result, we may want to get it back in terms of x and y or what have you in order to more cleanly see what's going on. Well, the process we use is called eliminating the parameter, where to eliminate the parameter, generally what we do is we try to isolate our values x and y as best we can, and then rearrange using some form of known pattern to get rid of that t value and put everything back in terms of x and y, where we just have to be very careful about what goes on in terms of our domain as defined for t. But the best way to understand this is to look at an example. So for this example, we want to eliminate the parameter for the equations x equals 6 cosine t, y equals 4 sine t, along the interval from pi to 2 pi in terms of t, and then use what we get to graph the plane curve. So what we need to understand here is what our goal might be, where because we have something in terms of sine and cosine, what we're going to build our approach around is the Pythagorean identity. That is, 1 is equal to sine squared of t plus cosine squared of t. If we can get a sine and a cosine both squared, then we can make some replacements in terms of just x and y. And that's actually pretty straightforward in this case. As for x, we have x is equal to 6 cosine of t. So we can say that x over 6 is equal to cosine, or if you prefer, x over 6 squared is equal to cosine squared. And then similarly for sine, because y is equal to 4 sine of t, I'm going to skip this little middle step in here. I'm going to divide over the 4. We'll have y over 4, and then I'm going to square it, is equal to sine squared of t, for the exact same reason as we had in the previous case. So if we add these two up, we'll end up having cosine squared of t plus sine squared of t. Well, that's equal to 1 to be sure, but that's also equal to x over 6 squared plus y over 4 squared. So we can say that instead of looking at this in terms of cosine and sine, in terms of our parameter t, we will have x squared over 36 plus y squared over 16 is equal to 1. Where this, flipping back to 9.1, is the equation for an ellipse centered at the origin with major axis horizontal and having value 2a equals 12 and minor axis being vertical with value 2b equals 8, where in this case, because we are going from pi to 2 pi, you can think of what we're doing here as graphing the bottom half of that ellipse along that path for t. Again, it's important there to understand the direction and, in a sense, speed, as it were, that we're flowing along in this graph in terms of that equation, which is a little bit cleaner if we look at it in terms of x and y. And the last thing we're going to see here is how we can kind of go in the other direction, that if we have some relationship xy that we want to parameterize, that we want to represent with t, we'll see there's a pretty straightforward way to do that. And that's what we'll finish with.